Hello everyone, my name is Tina. Today I'm going to share some basic knowledge about TCP and UDP. I will introduce the differences between TCP and UDP. In this lesson, you will learn the basic knowledge of TCP and the basic knowledge of UDP. This is the agenda for today's lesson. First, I'll talk about TCP and UDP, their introduction, their transmission behaviors, and their features. Second, I'll have a brief introduction of socket programming. Third, I'll have a comparison of TCP and UDP. Okay, today I would like to talk about the two protocols reside in transport layer, TCP and UDP. They are both protocols regarding transmitting data over Internet, but in their own ways. Today we will talk about how they work and the differences between TCP and UDP. Okay, now let's take a look at what TCP is. TCP, which is the Transmission Control Protocol, is used with IP to transmit data over the Internet. The entire suite is often called TCP IP. The Transmission Control Protocol provides reliable, ordered, error-checked delivery. To establish a connection, each device must send a SYN and receive an ACK for it from the other device. Conceptually, we need to have 4 control messages passed between the devices. However, it's inefficient to send a SYN and an ACK in separate messages when one could communicate both simultaneously. Therefore, in the normal sequence of events in connection establishment, one of the SYNs and one of the ACKs are sent together. This makes a total of 3 messages, and for this reason, the connection procedure is called a 3-way handshake. To provide basic reliability for sent data, each device's TCP implementation uses a retransmission queue. Each sent segment is placed on the queue and a retransmission timer started for it. When an acknowledgement is received for the data in the segment, it is removed from the retransmission queue. If the timer goes off before an acknowledgement is received, the segment is retransmitted and the timer restarted. Just as TCP follows an ordered sequence of operations to establish a connection, it includes a specific procedure for terminating a connection. As with connection establishment, each of the devices moves from one state to the next to terminate the connection. In the normal case, each side terminates its end of the connection by sending a special message with the FIN bit set. This message, sometimes called a FIN, serves as a connection termination request to the other device, while also possibly carrying data like a regular segment. The device receiving the FIN responds with an acknowledgement to the FIN to indicate that it was received. The connection as a whole is not considered terminated until both sides have finished the shutdown procedure by sending a FIN and receiving an ACK. Features of TCP. First, connection-oriented. An application requests a connection to destination and uses connection to transfer data. Second, point-to-point. A TCP connection has two endpoints, no broadcast and multicast. Third, reliability. TCP guarantees that data will be delivered without loss, duplication, or transmission errors. Fourth, reliable connection startup. TCP guarantees reliable synchronized startup between endpoints using three-way handshake. Okay, now let's talk about what UDP is. UDP, User Datagram Protocol, is a simple OSI transport layer protocol. With UDP, computer applications can send messages called datagram without prior communications to set up special transmission channels or data paths. UDP is suitable for purposes where error checking and correction is either not necessary or performed in the application. UDP uses a simple transmission model with a minimum of protocol mechanism. It has no handshaking dialogues and thus exposes any unreliability of the underlying network protocol to the user's program. Here we can see the picture. PC1 just sends images and doesn't care if PC2 gets the images or not. And it does not wait for any ACK. This kind of behavior makes UDP transmit more data in a certain period of time, but it does not guarantee for reliability. Features of UDP. First, connectionless, achieved by transmitting information in one direction from source to destination without verifying messages. Second, unreliability, allow individual packets to be dropped. Third, time-sensitive. Lack of retransmission delays makes it suitable for real-time applications. Fourth, multicast. UDP can apply to multicast application. TCP and UDP are often used with socket application. Here we can see how TCP and UDP are being applied. A network socket is an endpoint of an inter-process communication flow across a computer network. Computer processes that provide application services are referred to as servers, and create sockets on startup that are in listening state. These sockets are waiting for initiatives from client programs. A socket address is the combination of an IP address and a port number. As you can see on the right-hand side, we usually use UDP port 69 for TFTP service, UDP port 161 for SNMP service, TCP port 21 for FTP service, and TCP port 22 for SSH service. Okay, now let's see a comparison table of TCP and UDP. This is a comparison table of TCP and UDP. Connection. TCP is a connection-oriented protocol. UDP is a connectionless protocol. Usage. TCP is used in case of non-time critical applications. UDP is used for applications that require fast transmission of data. Speed of transfer. The speed for TCP is slower than UDP because of error checking for packets. UDP is faster because there is no error checking for packets. Reliability. For TCP, there's absolute guarantee that the data arrives and remains intact with the retry mechanism. For UDP, there's no guarantee that the messages or packets will reach at all. Weight. TCP is heavyweight. TCP requires 3 packets to set up a socket connection before any user data can be sent. TCP handles reliability and congestion control. UDP is lightweight. There is no ordering of messages, no tracking connections. It is a small transportation layer design on top of IP. This table is very important that I hope you can remember it. That's all for today's lesson. Thank you for listening.